everyone to today's webinar. In this webinar, I will present a full introduction to EnvisionTEC's most versatile technology, the Envision One cDLM. Before we begin, please wait until the end of the webinar to submit any questions you might have. In order to help us better support you, please complete the exit survey as well. My name is Miguel Gomez. I'm the Technical Services Manager at EnvisionTEC, and I've been here with EnvisionTEC since 2015. So let's begin with an overview of the DLP and cDLM technologies. In order to understand what makes the Envision One cDLM different, I will introduce you to the exciting new features with an overview of some of the external and internal hardware in the Envision One RP software. I will introduce the materials available for the Envision One, including several new materials, and we will end with a closer look at one of these applications, which is the COVID-19 NP test swabs. So to understand the Envision One cDLM and cDLM technology, it's best to know a little bit more about EnvisionTEC and DLP technology. EnvisionTEC was founded in 2002 with the release of the first DLP 3D printer and the first printer capable of printing wax. EnvisionTEC has become a global provider of professional grade 3D printing solutions with 6 process technology platforms and 45 plus model configurations. EnvisionTEC's 3D printers are utilized in markets including dental, audiology, bioprinting, aerospace, automotive, jewelry, and entertainment. In 2014, EnvisionTEC received FDA approval on a 3D printed restorative crown material. And in 2016, EnvisionTEC was the first to receive FDA approval on both a splint material for eGuard and denture material for eDenture. In 2020, EnvisionTEC received FDA clearance to manufacture NP swabs using our very own eGuide soft material. So what is DLP technology and how does it work? DLP uses a high-definition projection system to quickly stamp out a full image exposure one at a time, which makes it much faster than SLA technology. Pixels can be cured to a different depth. This is known as volumetric pixel, offering substantial edge finishes and edge finish improvements. EnvisionTEC's patented contour grayscaling software controls the degree of white and gray in each pixel, allowing for a smoother surface finish and extreme accuracy. In the diagram in the slide, we see a representation of the DLP process. The light source, which is just out of frame, is located inside of the body of the printer. The light source is projected and reflected off of a precision optic onto a DLP chip. And from there, a light is reflected up through the lens where it's projected into the material tray. The entire process happens almost instantly. In this diagram, a 3D printed ring is adhered upside down onto the build platform, and the light is exposing the final layers of the ring's prongs. So let's look at a brief overview of the range of printers currently offered by EnvisionTEC. On the left-hand side, we have the Vector 3SP. 3SP technology utilizes a laser to rapidly scan, spin, and selectively photocure resin in a unique approach that is proprietary to EnvisionTEC. Next to the Vector 3SP is the P4K, the newest release in the Perfactory series. The P4K uses a 4M pixel projector and artificial intelligence in pixel tuning to deliver extremely high quality models. On the right side of the slide, we have our desktop family of printers. Center is the Vita, which has a build envelope of 140 by 79 millimeters. The Micro Plus XL to the right of the Vita, which has a slightly smaller build envelope of 120 by 74 millimeters, which brings us to one of our latest patented developments, the cDLM, or continuous digital light manufacturing. EnvisionTEC first filed a patent for continuous printing in 2006, and this patent was granted in 2011. 5 years later, the Micro Plus cDLM was released, closely followed by the Vita cDLM, pictured to the left of the Vita. The Vita cDLM has a build envelope of 145 by 81.5 millimeters, making it slightly larger than the standard Vita. The cDLM technology, with its reduced separation forces, allows models to print faster, less supports, which translates to faster production and less post-processing time for supported models. And finally, we have the Envision One cDLM, our best-selling printer in the cDLM family, with a massive build envelope of 182 by 102 millimeters. The Envision One cDLM is the largest, most advanced desktop 3D printer ever created. It is a bigger, faster, and easier to use, and more innovative than all the other 3D printers on the market. The Envision One is also CE certified and certified in Canada. So let's go back to cDLM, or Continuous Digital Light Manufacturing. This technology speeds up the DLP process by adding a thin layer of oxygen between the layer being cured and the material tray. This layer of oxygen inhibits resin from curing, which in turn adds many exciting properties. The first advantage of the cDLM is speed. The DLP process requires each layer to be exposed one at a time, with pauses between each exposure for separating and repositioning of the build platform. The oxygen utilized in the cDLM technology reduces the separation forces between the material tray and the build platform. Less separation forces results in a much faster print because we no longer have to pause and reposition the build platform between each layer. This in turn cuts seconds off of the time needed to build each layer and the overall printing time. For example, with orthodontic models on the Envision One cDLM is about 30% less than other leading continuous technologies. In common continuous 3D printing systems seen on the market today, oxygen is typically added below a thin rectangular piece of oxygen permeable film that covers the entire build area. That film allows just enough oxygen to penetrate and create an oxygen-rich liquid zone, shown in the diagram as the white halo just below the printed model. This zone is the area where oxygen and photopolymer resin commingle. Because oxygen inhibits polymerization or curing, nothing cures in this zone, which allows for 3D printing in a free space directly above this area. Unfortunately, adding oxygen below a flexible film inevitably causes the film to tempt or rise more in the center than the outer edges. This means the film has a dome shape during the entire printing process, and the oxygen-rich liquid zone is also domed. This means that parts are no longer 3D printed on a flat surface, even in the free space right above this oxygen-rich liquid zone. Referring back to the diagram in the slide, we see that the dome causes visible variation across the build area of about 400 microns. This is almost half a millimeter, which results in inaccurate models. EnvisionTEC note of the accuracy issues created by this dome effect and released a patented domeless material tray in order to remove the oxygen bubble and evenly control the pressure of oxygen across the entire surface of this material tray. One of the most important requirements for accurate 3D printing is a flat parallel build surface across the entire build envelope. This is necessary because if there's any unevenness between the material tray and the build platform, this paper-thin layer of resin will not be cured in even Z-slices, and accuracy will be compromised, as we saw in the previous slide with this dome effect of about 400 microns or 0.4 millimeters. In this slide, we see a diagram of the domeless material tray in action. The dome effect has been completely removed, and in its place, we have a flat, even material tray surface with a continuous line of oxygen-rich liquid zone. An even accuracy across the build envelope with a maximum deviation of plus or minus 50 microns. So let's take a closer look at what makes up this domeless material tray assembly. On the right side of the slide, we have an exploded view of the Envision One cDLM domeless material tray. Beginning at the top, we have an oxygen permeable film, followed by a material chamber. Below the material chamber is the oxygen chamber. The vent holes allow for the oxygen to enter and exit the chamber in a regulated manner. The glass panel is the final part of the assembly, located on the bottom of this domeless material tray. Light is projected through the glass panel, through the oxygen chamber, through the film, past the oxygen-rich liquid zone, and onto the resin in the material chamber. The Envision One cDLM domeless material tray is a consumable and should be replaced after 300 prints in order to maintain an optimal printing conditions. The replacement material tray is $400, whereas the same type of product on the Nexten 5100 by 3D Systems is about $1,000 for a replacement. And the Dentaform by Structo has hidden costs that are even more detrimental. The Dentaform utilizes an LCD display that is not designed to interact with UV light. The UV light is used during every print, and so the LCD degrades and needs to be replaced every about 2 weeks. This is for $300, along with an extra $100 for the clear nonstick film that is also a part of this process. So in continuous printing, the light intensity must be powerful enough to penetrate this oxygen-rich liquid zone and relay enough light or energy to the resin above this zone in order to build models accurately and quickly as the build platform advances at more rapid speeds. Which brings us to the second exciting feature of the Envision One cDLM. This is the 385 nanometer projector. Currently, most 3D printers on the market use a 405 nanometer wavelength light source, which was designed kind of for standard film projection. The industrial 385 nanometer projector utilized by the Envision One was designed and optimized specifically for 3D printing. This projector has a LED light source that does not require warm-up time and does not require any lamp replacements. So when talking about 385 nanometers, the 385 nanometer wavelength is a shorter UV wavelength than 405 that results in a more precise printed model and overall better accuracy. A shorter wavelength focuses the curing field. With the 385 nanometer wavelength, 96% of the part is cured throughout the printing process, whereas with the 405 nanometer wavelength, that curing is only about 80%. This leads to light bleeding and curling issues. So the 405 nanometer has a higher chance of curling during post-processing. This is due to the 80% cured green model that is produced by the printer, with still 20% left to cure. Whereas with 385 nanometer wavelength, the green model is cured during the printing process to 96% of the way, which leaves only 4% to cure during post-processing. This reduces the chances for curling by up to 5 times. Light bleeding is also the effect of exposing light and curing material outside of the actual target area. As you can see in the slide, the top model was printed with a 385 nanometer projector. The bottom model was printed on a 405 nanometer projector. The top model more accurately represents or reflects the intended design with clean, sharp edges and a smooth surface. With translucent materials like the E1 guide and the E1 guard, the 385 nanometer LED projector gives us a clear surface finish, and EnvisionTEC's patented contour grayscaling technology takes this one step further, allowing for an XY resolution boost from the native XY resolution of 93 microns to 60 microns. The Envision One cDLM also features dual linear slides in the Z-axis assembly. This gives the build platform superior stability and control throughout the print, and eliminates shift lines in the printed model. For data transfer, the Envision One has both wireless and wired network capabilities. An Ethernet port is no longer needed to be within the range of the printer, as the printer can easily connect to the network wirelessly. If both wired or wireless networks are not available in the printer's operating space, the Envision One has 3 USB ports for data transfer, 1 easy access port in the front and 2 on the back of the printer. The Envision One cDLM also shows off a new user interface called the DLPCS, or controller software, that is extremely user-friendly. The 7-inch touchscreen display works beautifully with this new simplified controller software with iPhone-like icons. The controller software also prompts the user whenever a new controller software update is available. Lastly, the Envision One cDLM has a massive build envelope of 182 by 102 millimeters, or roughly 7 inches by 4 inches. This is the largest EnvisionTEC desktop 3D printer to date, and provides plenty of platform space for dental models during their print. For reference, this is only 10 millimeters shorter in the X direction than the Carbon M2. The PCA2000 is the recommended parts curing apparatus for the Envision One. The PCA2000 uses a unique system of LED light sources that use both 310 nanometers to deep cure and 405 nanometers for the perfect surface cure of each part. The PWA2000, or the parts washing apparatus, is recommended for the cleaning of any uncured resin from any 3D printed models. To use the PWA2000, simply immerse the objects directly in the tank using a basket, select the appropriate wash program, and then use the basket to extract your objects once the cycle is complete. The tank uses minimal liquid, reducing cost and environmental impact, and also removing used liquids can be done easily without the risks of spills or drips. Going on to the software, the Envision One RP software has an all-new and highly intuitive layout. All necessary tools are readily available, no subfolders or tabs needed for the 3D printing workflow. You can easily import a part, rotate, and add supports, nest, export a job file all directly to the printer in a matter of minutes. This is easy to use for beginners and advanced users alike. So let's take a closer look at the Envision One RP software with a demo. On the screen, we can see that we have the option to create a new project. Within this new project window, I am able to do a few different things. So I can jump right into my new project. I can go into my recents and start up a recent project. And also, if I am new to the Envision One RP software, I can also directly from the software itself launch videos to be able to learn how to use the software. Or if I want to get a refresher course or learn about the other features that are available, I can do so within this tab. Going back to the new project, I'm able to select my printer. We're going to be using the virtual printer, but I can see the network printers that are available as well. So I'm going to use a virtual printer for this demo. I can also select the material. We're going to stick with eModel Light, and I can choose a layer thickness. Once I have my material and my layer thickness selected, I also have the ability to choose a build style. A build style is proprietary to each printer. So if you have 2, 3, 4 printers in your building, you're able to select the build style that pertains to that specific printer. Then we can hit create. So now we're going to import a file to get started with showing off the software. I'm going to hit the import button, and I'm going to select a model. As you can see, the screen says loading and healing. The Envision One RP software automatically heals any missing surface, any surface triangles that are having issues, any intersecting or overlapping triangles, any holes. So when you pull in your model, once the model's in the software, it's a fixed and ready to print model. Within the software, I'm able to use the middle mouse wheel to scroll in and out, zoom in and out of the software. I can also press down on the middle mouse wheel and pan left and right. I can right click to rotate, and I can left click to select. Next, we're going to talk about the options in our toolbar here. So the first tool was the import. Second tool we have, scale, which in the dental space is not very common to be used. But however, you can choose to scale using a decimal point, or you can also choose to scale by a specific factor in one direction. This is all locked, but you can choose to, let's say you want your X to be 80 millimeters, it'll scale everything proportionally to the correct size. Again, it's not really used too much in dental, but the option is there. My next tool is my orientation tool. So I'm able to add here to this section. Let's say I wanted to tilt it in the X by 15 degrees. I can type in 15, and now my model is 15 degrees angled. I can also have the choice to quickly rotate by 90 degrees using this button, and I can do this in the X, Y, and Z axis. The next thing I can do within the same tool is the select base or change orientation option. So if I click on select base, as you can see now I'm in select base mode. So if I wanted this bottom surface to be the flat surface that's touching the plate, all I have to do is click select base. Then as you can see, there's a nice arrow that kind of shows you what that would look like, or which surface would be facing down. So if I click any of these surfaces, it'll make that surface that I clicked the down facing surface. Here's another flat surface here. But of course, we want to print this model flat to the plate right against this surface here. And the reason we would print this one flat to the plate, just to go back to the way that the printer uses oxygen to reduce separation forces, and also the domeless material tray that allows us to print flat to the plate without needing to worry about the dome effect. So this is why I would choose to print this model flat to the plate. So we're done selecting our base. Lastly, we have some options here where if you didn't want to have to select any base, let's say the model was imported just like that. If I just want to automatically jump to the flat surface, I just hit place on large flat surface, or the largest flat surface, and hit apply, and it automatically does the work for us. And the nice thing about this tool also is you can have all of your models selected at once and apply for all of the selected models. I can also choose to tilt my model within this window and minimize print time. But for this dental model, we're just going to stick with, again, printing it flat to the plane. We're going to skip this feature here, this fourth feature, because we're going to come right back to it. And we're going to jump to our positioning tool. So here I'm able to, if I'd like, move it in increments, or I can censor it on the platform. I also have the option to create a copy or multiple copies. I can also choose the amount of spacing I want and automatically place all of my models. So for example, I can change this to 1 millimeter, hit apply. And as you can see, my models are placed about 1 millimeter away from each other. Going on to the next tool, we have our supporting option, which we're able to modify any of these quick settings here. Tip thickness would modify the tip of the actual contact point to the actual file. Beam thickness is the rest of the point going down from the tip to the actual platform. And then we have a few other settings here, and we have also some advanced settings that we can modify. These are described here. So A through, it looks like I, are all here, and we're able to modify these if we choose, and we can also save these options. Save as, upload new, or restore defaults. However, what I'm going to do is I'm just going to show you guys how the support feature works. So I'm just going to go ahead and hit generate selected with the base plate enabled. As you can see, my models have now been supported, and I can select it, move these away from each other, just so that my bases aren't merged together. And the nice thing about this base plate, I wouldn't use a base plate for this specific model. I wouldn't even put this model in supports. But to show you guys what's nice about the base plate, let me zoom in. So as you can see, this model is named E1 Model Light Aligner. When you're printing copings and crowns, you're able to support your copings and crowns, enable the base, and you're able to look at what that model is called, or be able to identify what coping or what crown that it specifically belongs to, or what case it belongs to. So you no longer have to individually tab or tag your copings and crowns. You can just rely on the actual base. If I wanted to change the name, I simply right-click on the model, rename, and I can just call it the case number if I'd like. And so now my actual base is called case 23456. Now, if you didn't like the base plate, if you wanted to save some resin, and of course, if your models are already labeled, then you can just disable the base plate. And we typically recommend a minimum of 4 millimeters of supports. So I'm going to set that to 4 millimeters and hit generate selected. As you can see, there's less material consumption with this model, and also a little bit quicker build time because I'm not, a millimeter above due to the base plate. So if you wanted to save some resin and a little bit of time, I would recommend removing the base plate with your supports. Okay, so now we're going to discuss how to send the job directly to the printer. So I'm just going to select the models, and for the sake of demonstration, we're going to hit print, and we're going to rename this test print, and I'm going to click save job. Now, if I had a printer on the network selected, I could easily hit send job to printer, and it would automatically create and upload this job directly to the printer. I wouldn't have to transfer it on a thumb drive or anything like that. But I'm just going to hit save job to show you how the process would look. I'm going to save it to my desktop. It's going to go through each and every layer that's being processed, and it's going to create a new image file for each of those layers. And it's also, during this entire process, calculating the contoured grayscale of the individual layer. which is going to give you that extra defined surface and that better accuracy. Once the job is complete, we will be prompted with a job is complete icon or folder or prompt, and then we have the option to just continue, or we can also open the folder if we'd like. I'm going to go ahead and hit continue because I want to show you guys the two newest exciting features that the Envision One P has to offer. The first feature, which was highly requested from a lot of our customers, we heard all those customer voices and we went to work right away to try and implement this feature as quickly as possible. That feature is the labeling feature. So now customers that are using software to design their files if that software they're using to design doesn't have the labeling feature, this customer no longer has to open up a third-party application or third-party program to apply a label to their models anymore. They can just design their files, pull them directly into the Envision One RP, and they can orient, support, nest, and label all within one software. I'll show you how it works. So I'm going to select this model here, and we're going to label it with case 2, 3, 4, 5, 6, and I'm going to hit place. It hides, once I hit the place, it hides all the other models that are not selected, so I'm able to place this label really wherever I want on the model. So I'm going to place it where we typically have labels on these models, which is right here along this wall. So all I have to do is basically orient the model or place it wherever I'd like on the model, and then on the left side here I can change the font size. So if I want it to go smaller, I can. If I want it to go bigger, I can. And also, if I wanted to engrave this deeper than 300 microns, I can do that as well, and I can hit apply. Just give it a second. And there we go. So even though there was texture on the side of this model and it wasn't a perfectly flat surface, I was able to label this model again within the software. The next exciting feature that we wanted to talk about is the auto vertical placement. So let's say I have multiple models that I would like to print. All right, let's duplicate a few of these. But I can't fit them on the build plate. Let's say these are larger models and I've run out of room. So just to show you guys an example, I'm going to just add a few extra models that we're confident would not fit on this plate flat. So if I wanted to, traditionally, if I wanted to orient these vertically, I would have to go through and manually align these models. Also, I would have to support them, and I would have to orient them in a way that gives me the highest degree of accuracy. So the software that I'm about to show you, or the feature that I'm about to show you, automatically orients the models vertically, automatically supports them with only 2 points of 2 breakpoints, where it makes it easy to break the supports off, and it also orients it, angles it to get the highest degree of accuracy, all at the same time. So let's go ahead and go into the hyperprint option, and I'm going to select A-type jaws. The reason why it's called A-type jaws is because the teeth or the model that we're working with is shaped like an A, okay? So we're gonna hit apply. And again, the software is basically calculating the bottom surface, it's calculating the angle, it's adding supports, it's extruding certain surfaces to make sure that so again, in this, as you can see, we have plenty of room on this plate. So not only did I just add an extra model that I couldn't fit before, I could easily add 5 or 6 more models to this plate if I really wanted to. So just to give you guys a closer look, the models are now vertical. They're oriented, they're pitched about 15 degrees. And what that does is if there's any down-facing surfaces, like you see here, this feature of this tooth that's kind of down-facing a little bit, when I printed, if I printed completely vertical, I would lose definition there. But because I'm not orienting it completely vertical, I'm able to keep all the definition and able to keep all the accuracy. And again, the software does all of this on its own. This requires zero real effort from the operator side. And so it's super easy to use. So all I would have to do is click on the A-type jaws, apply the hyperprint, and then I'm ready to send my job to the printer. Okay, so let's go right back to our presentation. Now that we understand the Envision One RP and its latest features, let's take a closer look at the materials we have available for those models and their applications. EnvisionTEC is constantly innovating and constantly growing, and our material offerings really reflect that. The Envision One cDLM currently has 17 dental materials available with a wide variety of materials to meet your specific needs. Splint Soft for EnvisionTEC is a 3D printed resin ideal for printing splints and night guards. It is fully biocompatible in its compliance and international medical device regulations and standards. Its robust formulation has 3 years of guaranteed shelf life, is color stable, and is validated in EnvisionTEC DLP and cDLM printers. Splint Soft for EnvisionTEC combines the strength needed to protect teeth with added flexibility for better patient comfort, for precise and strong, smooth finished parts that are not brittle. The abrasion-resistant formula is easily polished and is also easily cleaned by the patient. E1 tray is 3D printing material used for producing individual customized impression trays. Dental impressions can be used for preliminary impressions, final impressions, bite registrations, and they're also used for prosthodontics, orthodontics, dental crowns and bridges, oral and maxillofacial surgery, and diagnosis, mouth guards, whitening trays, even for permanent dental records to document before and after phases. E1 tray's minimal inhibition layer promotes optimal polymerization of the impression material. The high elongation at break combined with the translucency of the 3D printed component means that the practitioner always has control during the impression process and when removing the tray from the mouth. E1 denture material is biocompatible material suitable for printing all types of removable denture bases. This material has low shrinkage compared to standard PMMA denture materials, which results in excellent fitting customized denture base for natural-looking appliances. E1 denture has excellent mechanical properties comparable to conventional denture-based materials. Dentures have always been a difficult and time-consuming product, especially when made using traditional processes. 3D printing expedites this process. There are 2 main types of 3D printed dentures. There's the monolithic denture and the 2-part dentures. The monolithic denture is a single model comprised of denture base and teeth with no assembly required. Monolithic dentures are printed in one material, so more time must be spent in the stain and glaze to really transform that denture base into a tissue color. The 2-part denture is an assembly of the 2 separate prints, the denture base in E-denture and the denture teeth in the E-dent. The 2-part denture requires more time for assembly, but less characterization is needed. Here we see a fantastic example of a fully characterized monolithic denture. This was printed on the EnvisionTEC Vita and characterized by Valerie Cooper McMillan and John McMillan. E1 Model Beige and E1 Ortho Shape are low-cost orthodontic materials for generic suck-down models. E1 Model Light and E1 Model Peach are high-resolution materials that are ideal for crown and bridge models and orthodontic appliance models. E1 ABS Tough is a white material available for dental and orthodontic use. And ESEP Free allows for you to directly build orthodontic appliances without a separator. It's also easy to carve. eDent 400 comes in several different shades. This is a biocompatible and FDA-approved material for the accurate 3D printing of crowns and bridges. eDent 400 MFH can also be used for 3D printing of very tough veneers that are extremely accurate and have a very fine surface finish. It can also print denture try-ins. E1 Guide, E1 Guide 2.0 is a strong translucent material used for high precision surgical drill guides and for use in implant surgery. The material is resistant to disinfectants and can be sterilized using gamma rays and autoclave without affecting dimensional stability. E1 Gum is a material suitable for soft tissue samples. Press E1 CAS and E1 WIC 402 LED are wax-filled photopolymer materials for the production of full anatomical crowns and bridges. You can also print partials as shown on the slide. These materials have a moderate amount of wax, which allows for its quick and easy burnout. In the wake of the COVID-19 pandemic, EnvisionTEC took steps to ensure the safety and support of our customer community. We worked with healthcare leaders to identify 3 main areas where EnvisionTEC's 3D printing expertise could really be used: ICU ventilator splitters, personal protection equipment production, and the NP swab, the NP collection swabs. EnvisionTEC's NP swab is a proprietary and confidential STL file subject to NDA. When the NP swab STL file is printed in our new eGuide soft material, the swab has the most flexibility and softness of tip. The collection of the tip can be bent 180 degrees without breaking, making it extremely safe. The EnvisionTEC NP swab passed a 100-patient clinical study at Harvard BIDMC and performed better than all the other 3D printed swabs in terms of patient experience. The EnvisionTEC NP swab is the only swab that can be steam sterilized at the standard 270 degrees F without degradation in mechanical properties. According to Dr. Rami Arnaut, MD, Associate Director of the Clinical Microbiology Laboratories at the Beth Israel Medical Center, analytical results were positive with a high level of concordance with the reference swab, and the subject's results showing that the EnvisionTEC swab performed neutrally or better than the other test swabs. To learn more about the NP swabs, visit COVID-19 page on our website, EnvisionTEC.com. Okay, the floor is now open for questions. Please type any questions you might have in the question section, and I will do my best to answer them. Thank you.
Thanks so much, Miguel. That was extremely detailed, so much so that looks like we haven't had any questions come in. I'm just reviewing here. Yeah, looks like you covered everything, which is phenomenal. That was great content, great presentation. I will make a quick note to everybody that if you do have any questions post-webinar, please feel free to email us directly at zahn@henryschein.com. And we are happy to answer questions that way. Additionally, if there is anything that you missed in the webinar, we will be posting this on demand, both on our website and our YouTube channel. So at this point, that ends the webinar. Miguel, thank you so much for your time this afternoon. We really appreciate it.
No, thank you guys for having us. We appreciate it.
Miguel, actually, before we sign off, it looks like a couple of people here did think of some questions that they would like to address. So I'm going to read a couple of these to you while we still have time. This one here is from Sean. Is there a way to put a flat base plate on hollow models?
A flat base plate on a hollow model. So like basically if you wanted to put There is a feature in the software that allows us to add a base plate. There's also, if you would like to request this feature to be enabled, we can also add channels. So if you do have a hollow model that does have a base plate, we can channel it. Now, if you're asking about the base plate in the supports, in the support section, yes, you can add a base plate to really any model you would like to support, from crowns to dies to even dentures. You can really put base plates on anything.
Great, thanks, Miguel. Here we have a question from Jenna. Does Asiga use oxygen layers?
I do not believe they do, but I am not too familiar with their equipment.
Okay, Jenna, so you could always look into that separately, or email us directly at Zahn@henryschein.com. Let's see here. We have another question. How do you prevent models from sticking to the build plate? Many times they stick very hard.
So the one thing that we recommend is if you're having a hard time removing the models from the build plate, one thing that we advise is you take the build plate out and you let it soak a little bit, not completely in alcohol, but you basically just coat the model or the base, the platform where the model is touching. You coat that with a little bit of alcohol, and it kind of starts to break the suction. So models that are hollow and are printed flat on the plate can create a lot of suction, and so that's why we always advise for there to be channels on the bottom of hollow models. So if you are printing hollow models, make sure you are applying a channel on the very bottom to allow for suction to not be that great. But if you're printing a solid model, I would advise to either add a little bit of alcohol before you try to remove the model from the plate. And also, if you'd like to use a small handheld spatula with a very, very small, like if you have a small mallet or rubber mallet, you can easily tap away to allow for that suction to be released.
Thanks, Miguel. Another question here from Zahn. Will the E1 print soft tissue material?
Yes, we have the E1 gum material available. It is a soft tissue, and it is available today.
Perfect. Question here from Mark. Is there a fee for the software after the warranty period?
So if the printers are under warranty, all the software features and all the software upgrades are all fully inclusive. When it comes to the end of the warranty, I'm not 100% sure what the warranty details all include, or what the once the warranty ends. I'm not really too involved with that. But if you could email Zahn at Henry Schein, they could probably answer that for you guys.
Perfect. Just a couple last questions here, Miguel. This one is from Leanne. Can you emboss with the labeling feature with the software? Also, can you label with logos?
So you cannot label with logos yet. It's only simple text, and you can engrave. There isn't an emboss feature, but if that is something that customers would like, EnvisionTEC is always open to feedback and suggestions, and we can definitely do an implementation for an emboss feature as well.
Perfect. Okay, thanks, Miguel. That wraps up all the questions that have come through. Again, if anybody else thinks of anything, please email us directly, Zahn@henryschein.com. And thank you, everybody, for joining us this afternoon. And thank you again, Miguel.
No, I appreciate you guys. Thank you so much. Thanks, everyone that joined.